Well, but when we're now bringing tangents and normals into things, things get a bit more involved, and some of the questions are longer. So this first question we're going to look at is find the equation of the tangent Do you still do dictation in English in school sometimes? People reading out and you have to write down and stuff? Or is that a lost skill? Find the equation of the tangent at the point 3, 1 on the circle x squared plus y squared minus 4x plus 10y equals 8. If we've got a question over here, is this differentiation? You're thinking tangents and normals, differentiation. Do you want it to be differentiation or not?
I want it because differentiation is quite nice.
It's not going to be differentiation. Right, we're going to ask ourselves another couple of questions. That's like part A. Part B for this question is going to be, what is the angle between the tangent and the positive x-axis? And I'll explain what that means later on if you're not clear. And then there's going to be a part C. What is the equation of the tangent?
Isn't part C just asked the same? Because that one's at a certain point.
Hang on. I think, yeah, I might have, well, we'll have a look as we go through. Have I done that backwards? We'll have a look. Right, first thing, find the equation of the tangent on the circle here. What do you think it would be useful to do first of all? Just from the work we've done on circles today. Don't even think tangents, normals, anything else yet. Go on.
Find the equation of that kind of radius.
Yeah, write it in the bracket form sort of thing.
Yeah.
Yeah, okay. So write this one equation down, x squared minus 4x, then leave a gap, plus y squared plus 10y, leave a gap, equals 8. That would be a good thing to do. Can anybody tell me then, in the bracket form, what am I going to get for my x bit, including the taking off bit? What am I going to get?
X minus 2 squared minus 4.
Yeah,
Is it
x.
plus 4 though?
I will be introducing a plus 4, which is why I need to take it off as well.
Oh yeah, because
Okay.
And then y plus 5 squared minus 25.
Yep. Okay. So then move the bits over to the other side, combine them with the 8. So we're taking 29 is being added on. What have we got on the right hand side? 37, yeah. So we've got then that the centre is, yep, 2 minus 5, and the radius is root 37. Okay, so there we go. Now, what I think it would be useful to do here is to do a sketch, to try and work out what on earth's going on in this question. So, have a go at just setting up a pair of XY axes, only a sketch, put the circle on it. Now try and get the circle centre in the right place. Try and work out what axes it crosses, because you know the radius is just over 6, isn't it? Square root of 36 is 6, so that's going to be 6 point something small. So you know the radius is 6 and a bit. You know where the centre is. Try and do your own little sketch of that. Just getting it crossing the right axes or not crossing the axes. And I do think part C of this question is unnecessary, as somebody said. I think I've done the same thing twice. Your sketch and my sketch, do they look vaguely alike?
I think it's just because your circle's a lot bigger than mine.
Right. I just wanted to show that because we know the height or the radius of the circle is 6, and this point here is 5 below there, you do need to show it goes above the x-axis.
I did that.
And because this distance here is 2, but it goes 6 left, it does cross that axis as well. So that's the crucial thing there. And this question is also talking about the point 3,1. And the point 3,1 must be over here somewhere. And it's talking about the tangent there. What's the important thing about tangents to circles? Yeah, they just touch once. No, I haven't got a ruler hidden in my pocket. There we are. There's a beautiful tangent drawn. I'll extend my x-axis. Now, it says find the equation of the tangent. We're going to do that bit in a minute. We'll look at the part B actually first. Okay, I know it sounds a bit strange, but we're going to do part B first. I think I need to rewrite this question. We are going to do what it says, we're not in the same order. So we're going to do part B first, the angle between the tangent and the positive x direction. So the tangent is a sloping line. What it's talking about the positive x direction is it going that way. So the angle that they are after here is this angle here, which I'll call theta. The angle between the tangent and the x-axis. Now I'm going to draw another line on here, another straight line which will help us. Can anybody think of another straight line which may be useful and in some way that's related to the tangent? Go on.
Would it be the normal from the point 3,1?
The normal. Where will that normal go? Because you're quite right.
Perpendicular through the tangent.
Yes. Can you tell me another point it might go through?
Oh, the centre.
Because from your circle theorems, tangents to circles, so circle theorems from GCSE, always created right angles to the radius. Okay, so we've got some circle theorem stuff coming in here as well now. So what can you tell me about the gradient of the tangent and the gradient of the radius?
What would be the negative reciprocal?
Yeah, okay. The radius and the tangent are perpendicular. Somebody over here used that word perpendicular before. Okay? So, from your circle theorems from GCSE, the tangent and the radius are perpendicular, which means at right angles to each other. And because perpendicular is such a long word, you might have come across that symbol for perpendicular.
What symbol?
That over there, horizontal line, vertical line, and a right angle symbol in it. Okay. So, from what we had over there, the gradient of the radius, he said, was a negative reciprocal. In other words, is equal to minus 1 over the gradient of the tangent. Okay, so that follows from how perpendicular gradients work. Now, if we look at the drawing, can I borrow your pink highlighting pen a minute, please?
Yes.
Thank you. If I put a line down here and a line there, and we look at that right-angled triangle a minute, we should be able to, from that right-angled triangle there, work out the gradient of the radius, because I've got a right angle here, I've got this point down here,
What's this?
that's that pink triangle, I've got that's at 2 minus 5, and I've got this point here is at 3, 1. So, what is the horizontal distance along the bottom of that triangle? 1. What is the vertical distance up the side of that triangle? 6. Okay, because I've gone along from 2 to 3, and I've gone up from minus 5 to plus 1. So what, therefore, is the gradient of the radius? The gradient of the radius is the up number divided by the across number. 6 divided by 1. So the gradient of the radius here is 6. That's done from that pink triangle. So going from what we had a minute ago, the gradient of the tangent, because they're perpendicular, will be minus 1 over that 6. So it will be minus 1/6. That's the gradient of the tangent. And now we're trying to find the equation of the tangent. So, what will the equation of the tangent look like? What does any straight line equation generally look like? What's the general thing for any straight line equation? Y equals mx plus c. And what have I just found? M. So y equals minus 1/6x plus c. We're just going to finish this. We've got 2.5 minutes or so left. We should just be able to finish this now, this bit. How am I going to find out what c is? And an x coordinate as well. Yeah, and what point do I know it goes through? What the question told me it went through?
3,
Yeah. So if I use the point 3, 1, where that 3 is my x number, and that 1 rather is my y number, and substitute in, I get y equals minus 1/6 of x plus c. If I go like that, that might help people. So I've got 1 equals minus 1/6 of 3. What's that? Minus 1/2. Yeah, plus c. So c must be 1.5, or 3 over 2, or 1.5. So the equation of my tangent, which is what I was looking for, will be y equals minus 1/6x plus 3 over 2. And because often people don't like fractions in there, what may happen here to make it look nicer? Times everything by 6. If you times everything by 6, you'll get 6y equals minus x plus 1.5 times by 6. 9. And because people don't like minus signs, some people might shift that negative x over onto the right, and we'll end up with that. All of those, there's nothing wrong with any of those answers there. Okay, the bottom one is like the nicer version, but that is the equation of the tangent. Okay, I'm just going to stop the video at that point.